We are continuing the series on how to handle the non-normal data. We often juggle around to find a right distribution, mainly when it comes to variable data. As variable data has to go through the normal distribution, whether the data has been normally distributed or not, that's a mandatory requirement to check first. And although AD Anderson Darling helps to find out the data normality to some extent. For example, if the data, the p-value mainly which comes out from the Anderson-Darling, the p-value is less than 0.05, that is 5%, which signifies the data is not normal. If the p-value is greater than 0.05, that is 5%, let's say 37% example, that means that data is normally distributed. So although we find that way, but if the data comes out to be a non-normal data, we often encounter three possible question comes in your mind. Should I try different distribution to check if my data will fit to any of the distribution? For example, we have Johnson transformation, we have Box-Cox transformation, we have Weibull transformation, and so on. Or second question, should I classify the data using subgroup? For example, some data I can classify into week, I can classify into any subgroup. It can be month, it could be any categorical value, it could be anything. Should I do that? Can I find that way? Or should I straight away find the transformation, right? For example, we can transform the data from non-normal to normal using Johnson transformation, using Box-Cox transformation, and so on. All these questions, we probably get it and every day, and it puzzle, all of us. So, but no worries, there is a simple solution. We are going to discuss something called individual distribution identification. The basic definition is that identify an appropriate distribution or transformation. It is both, it's a combo. And before you perform the capability analysis or control chart, anything, this is for normality test. When you are unsure whether your data follow a normal distribution or not. This is what we are going to discuss. I'm going to click on this and you have a directly like normal, exponential, variable, gamma and all that. But if you also have something called Box-Cox, this is distribution. And if you intend to modify the data or transform the data, you have Box-Cox transformation, you have Johnson transformation and so on. So what I'm going to do is that without going in detail of that, so I'm going to click help menu. So help menu gives me different thing, right? So it gives an overview, how the data has been arranged, and then if the distribution fit normal distribution, you have a exponential, variable, and if you want like exponential, you have a definition of exponential, right? So this is the exponential model. And then variable one, which is process capability, we use often we use this one. Variable distribution, which classifies the data, it gives a shape, and then we transform the data. This is one way, right? Or you have a gamma way method, right? Again, it is like reliability survival test. It is like exponential one where you find out the where goes that upper tail, right, of the distribution. So this, and then you have on top of it, you have the last resort, you have transformation. You can definitely do a transformation. How many transformation you have? 40 transformation you have, right? Normal, log normal, 3-parameter log normal, exponential, and 2-parameter exponential, variable, 3-parameter variable, large extreme value, and then small extreme value, gamma, 3-parameter gamma, logistic, and log logistic, and 3-parameter log logistic. So a lot of options you have, 14 distributions you have, right? To confirm your data is normal or not. So what we are going to do is that we're going to hit directly example, and we are going to do this example, right? Suppose you work for a company that manufacture floor tiles, and then there are concern about warping in the tiles, And to ensure the production quality, you measure the warping in 10 tiles each working day for 10 days. The distribution of the data is unknown. Whether it is normal or not normal is not known. Individual distribution identity allows you to fit these data with 14 parametric distribution. And then it also gives two transformation, meaning it gives like Box-Cox and Johnson also. So we're going to take the tiles and we are going to take that warping and then we are going to do it. Okay, let's see. So the data, I mean, the example directly there in a Minitab. So what I'm going to do, I'm going to click tiles, click here, and then you can have go to tiles. Just type tiles. T-I-L-S. Okay. So the tiles data has come up and so this is the data. We want to find out whether what natural way we find out using that the normality test, but we can also do it through quality one, right? So quality tools and individual distribution identification, right? IDI, easy to remember. IDI, individual distribution identification, and have a click on warping. So let's say some group is just one. Okay. It gives 14 different one, right? For the logistic, according to logistic is normal. Why it is non, I mean, sorry, not normal. So 1.2. And the same thing if you try lognostic is not normal. And then three parameter again non-normal. And Johnson transformation is it is transform the data successfully and it is normally distributed. You can see 0.799, that is 79.9. Confirm that it is a normal distribution. This is one. And all other things shows that non-normal. This is one. 4. And then you have the smallest extreme one. Let's see. Again, non-normal. Largest extreme, normal. If you look at the largest extreme, it shows a normal distribution. Gamma shows also normal distribution. And then three parameter gamma does not conform to normal. Yes, this is done. And then you have exponential method. Exponential method also confirm that this is not normally distributed. This is also not normally distributed. But Weibull confirm that it is normal distribution. You can see here. And three parametric Weibull, it also confirm that normal distribution. And then the lastly you have, so normality test. So the general Anderson-Darling one, right? The AD is Anderson-Darling. And it says that the data is not normally distributed because it is just 1%. We're supposed to have 5%. And Box-Cox, it has done that transformation now. After confirming, it is converting to non-normal data to this one. This is confirmed that is normally distributed. Not normal, not non-normal data, non-normal. So all of that, what I'm going to do, I'm going to combine using something called layout. So layout, I'm going to go and put it up here, put this up here, and put this up here, right? 1, 2, 3, 4, all that distribution has come. All the 16, it has given 16 actually. So along with the two, we have 14 distribution, and then we have two, the transformations. So let's see, it gives a complete eagle view. From this, if you want to identify which is transformation, this is transformation, you can see here. This is, I will call it as a T1, transformation one. And then you have another one. So let's find out where it is. Johnson, this is also a transformation, meaning it has found that non-normal data. it has already transformed into data, right? And all other is just a transformation. For example, the first one, transformation, distribution, right? So not a transformation, sorry, distribution one, and this is distribution two, and this is distribution three, and I'm going on distribution four, and this is distribution five, distribution six, and distribution seven, distribution eight, distribution nine, distribution 10, distribution 11, distribution 12, and then you have a distribution 13, and lastly you have distribution 14. So what it does is actually individual distribution identification. It gives you 14 distributions. How many distributions you get? You get 14 distributions, and you get two, there are the transformations, right? TX I will call it. Two transformation it gives. From there you can confirm if data is none. So what we see is that it gives a complete picture which we can use. For example, if you want to use, now it is absolute clarity, right? If I need to use the transformation, if I ended up having a decision that I can use the transformation, so there are two options. Box-Cox transformation will give you 57%, and then Johnson transformation will give you 80%, right? I can easily choose. Let's say I'm just choosing Johnson transformation. Exactly like distribution. In the distribution, out of 14 distribution, you can see here. So this is not normal. This is not normal, and you can. This is also not normal. This is anyway. It's a transformation, right? It's a distribution, and then you have Weibull is also there, and then you have parametric Weibull also there, right? I can use Weibull. And I think Weibull is a good option, but let's see if we have any other thing. Largest extreme also is a good option. If you have large data, gamma is also a good option. And then you also have some other example. So I think these four are the one. So that means out of 14, four come to be naturally distributed. Predominantly we can do using Weibull distribution. So how cool and amazing it is, right? So you have a only one line of data, meaning warping data you have of the tiles. And if you want to find out, you can easily find out how many distribution, 14 altogether 14 distribution it gives. And also it gives the how which distribution may fit for you, which is greater than 0.05. And also it gives the last resort, that is the transformation. It also gives how which transformation you can use it, right? This is how we can easily do that. And the same thing you can also do for any other example. Let me take one quick example of process capability. Let me delete the annotation. Let me take one last example. Let's say I'm just taking process capability. In the process capability, I'm taking non-normal data, and I'm just going help, and I'm finding the example. So this is once again the same example which we saw in tiles. This has been given in the tiles, but here in the tiles they have used Weibull distribution. You can see here Weibull distribution being used, right? Like this, we can find out for anything. For example, let's say if you want to find out Johnson, let's say we had another one in quality tools, the next to individual distribution, we have a Johnson transformation, and I'm just clicking on help. In the help, I'm just clicking on example, right? In the example, again, warping example has been given, so you can try to find out. I hope you find it useful. Please do like, share, subscribe my channel. You have a wonderful day.